Great. Well, thank you all for joining us for our webinar series with Community Efficiency Leadership Coalition. Uh, Today's webinar is increasing efficiency and reducing peak demand through urban heat island mitigation strategies. Uh, there's going to be a couple of objectives today. We're going to highlight emerging technologies and surface treatments that reduce heat and energy demand at the community level. Share case studies from coalition partners demonstrating measurable impact, and explore potentially policy funding and partnership opportunities to scale non-traditional energy efficiency solutions. Today, you'll also, if you're interested, you can receive one ICC CEU credit. A little bit about this series. It is hosted by the organization I'm a part of. I'm Sean Auckland. I'm the local government community program manager. We're part of SPEAR. I work for SPEAR. It's a South Central Partnership for Energy Efficiency as a Resource. And if you haven't heard of us, we are a small nonprofit. We cover Texas and Oklahoma as our region, but we're a part of a regional energy efficiency organizations across the nation. We work together on furthering energy efficiency with state energy conservation offices in the Department of Energy. We're also a member-based nonprofit. We're a 501c3. We have 65 members plus across the section of energy efficiency industries. And we really kind of focus on, oh, excuse me, I don't know why that happened. On education and collaboration, on clean energy, resiliency, and sustainability. Just want to cover, we have a lot of different things that we do within our organization, not just webinars. We also have roundtables. And then upcoming in September, we have an industry and policy workshop based here, based in Texas, and Austin, Texas at the AT&T Hotel and Conference Center. I manage the local government program that supports, again, city energy efficiency management, but as well as other local governments, and that includes universities, counties, state agencies. And we facilitate the sharing of best practices and energy efficiency while strengthening those relationships. And this is all the membership to be a part of the Community Efficiency Leadership Coalition is free, and it's sponsored by the State Energy Conservation Office, as well as all of the webinars that we provide and most of our educational opportunities. And I just want to go ahead and state real quick that with the policy workshop, I do want to highlight, if you are a CLC member or a part of the Texas Energy Advocates University program here in Texas, that you can attend our tour of the Carl J. Eckhart Combined Heating and Power Complex. It's at the very beginning of the SPEAR workshop on September 18th. And it's one of the largest campus microgrids in the country and generates 100% of the university's electricity, heating, and cooling. So it's pretty exciting, and we are looking forward to that. As well as our next webinar will be next week, and it's focusing on air quality and performance, so integrating building systems. And then I just want to cover a few housekeeping items. Questions are welcome in the chat. All our presentations will be posted on the SPEAR website. A survey will be provided in the chat and a follow-up email. So we'll have a follow-up email, as well as if you respond to that email and survey, you can receive the ICC CEUs, and it'll be mailed out within 3 days. And I see that there's something in the chat, so let me make sure there's no questions. All right. Well, without further ado, I am very excited to welcome our two presenters. Today we have Bill Updike and Eli Goldstein. And Bill Updike is the program manager for Smart Surfaces Coalition. And then Eli Goldstein is the co-founder for Sky Cool Systems. And I will go ahead and let you guys get started. And so I'll stop sharing my screen, and it's all yours, Bill.
Bill Updike with the Smart Services Coalition. Great to be here with you all. I spent a long part of my career in the green building and renewable energy construction world, and so energy efficiency is near and dear to my heart. Smart Service Coalition is a coalition of more than 40 organizations that are focused around transforming urban infrastructure to mitigate urban heat island, stormwater flooding, and create cooler, healthier, and more resilient cities. And our focus is really around the way to do this in an integrated fashion to make it the most cost effective that's possible. I think we all know that every year seems to be a new heat record these days, and certainly increasing. This map shows some of the modeled increases out to 2053, where nearly 2/3 of Americans will experience perilous heat waves according to the modeling. I'm sure you're all very familiar with the urban heat island effect, but if not, urban heat islands can be 5 to 9 degrees hotter than some of the surrounding rural communities, and quite a bit substantially hotter at night, where it gets even more dangerous from a human health perspective when you have multi-day extreme heat events. And some neighborhoods, this heat is not distributed equally. Some neighborhoods, often low-income communities, can be up to 15 to 20 degrees hotter than surrounding rural areas around cities. And so this is an extreme issue. It's a health issue, and it's something that we're focused on at the Smart Services Coalition. So what are smart services? It's kind of a wonky sounding term, but these technologies that we are talking about are all proven technologies, things that people are very familiar with. But there wasn't really an expression before to cover cool surfaces, green infrastructure, low carbon surfaces, permeable surfaces, and energy generating surfaces. And so coined this term some years ago, smart surfaces, to bring all of that under one rubric in order to really think holistically about surface transformations in urban areas. So my pitch here today is the idea of thinking outside the box, and the box being the building envelope at this point. We spent many decades in doing spectacular work around energy efficiency widgets in buildings, and building envelope improvements in terms of insulation and others. And my pitch here today for you all is for us to collectively start thinking about interventions that are outside of the building envelope that also can drive substantial energy efficiency and peak demand reduction. And part of the pitch is that we're starting to see diminishing returns, as you all are probably familiar with some of the other interventions, say, for example, in this case, insulation, where there's a certain point where the cost effectiveness and if you're someone who cares about climate change, the embodied carbon impact isn't really worth it after a certain point in time. And so we're starting to get to approaching some of that in the latest energy codes, and starting to think about other opportunities that are out there. And the other reason for this is that there are substantial externality benefits to surface transformations in cities that go beyond just energy efficiency or carbon or other things that people might care about. But we'll focus right now on the efficiency piece and on the peak demand piece. And so the modeling shows that cool roofs can lead to anywhere from 11 to 27% peak cooling reduction. That might equate to something more like 3 to 4% total energy reductions. Cool walls are being incorporated now more in buildings, cool wall technologies, and the research shows up to 27% HVAC savings using cool wall solutions. On the green roof side, you can see up to 84% lower thermal heat gain, and then there's benefits on the heating season as well for green roofs. Some of the modeling shows 13 to 33% savings depending on climate zone and project, etc. Some of the utilities and energy efficiency providers around the country are starting to actually fund tree planting, strategic tree planting, east, southwest facing tree planting for the purposes of energy efficiency. And even in a few cases, the state technical reference manuals are starting to allow the funding of trees and other, what we would call smart surfaces for the purposes of energy efficiency, and can see substantial energy savings there. There are newer technologies like passive rated cooling films and panels, and we have Eli Goldstein on the call here from SkyCool with a really interesting and cutting edge technology that is proving out to have substantive energy efficiency benefits. And the nice thing about these technologies, in addition to making the building more energy efficient, they also help to mitigate urban heat island and provide global cooling. And that, is a big part of our premise, is these combined surface benefits, like those combined benefits of passive rated cooling films and panels that help with energy efficiency, also help with global cooling, also help with mitigate urban heat islands. So that $1 of investment is leading to, $10 of benefits, $10 of value, or, that's a selected number, but you get the idea. And then there's, other benefits in terms of combined surfaces. Solar plus cool roofs can help increase the, solar power panel efficiency by, upwards of 10%, depending on location, etc., temperature. Same thing with solar and green roofs. So thinking about these things more comprehensively, citywide, but also in an integrated fashion to get those multiplicative benefits that you get from these types of interventions. On the peak demand side, our modeling that we're working on right now with various cities around the country shows that we can double the solar reflectance, the albedo of cities with different surface interventions. We can reduce peak summer temperatures by upwards of 5 degrees, and in some neighborhoods higher than that. The neighborhoods that have been historically disinvested, low income areas in particular, that are seeing that more extreme urban heat island effect. Interventions can reduce temperatures in those neighborhoods more than 5 degrees. The research shows that for every 1C or 1.8 F of temperature increase, it increases peak electricity upwards of 4.6%, depends on climate zone, etc. And increasing total electricity consumption upwards of 8.5%. So if we do this work in a comprehensive fashion citywide, we have the potential to reduce peak demand by, double digits, and total energy and electricity consumption as well. And so there's huge individual building benefits, but there's also very large city and society benefits to these different interventions. And so you get this multiplicative event that benefit that I mentioned before. So all of this led to the creation of our organization some years ago, and the creation of this program we call the Cities for Smart Surfaces program. So we're working around the country to in cities and metro areas, and this is a map of the places we have worked, the 5 cities we worked with previously, and the new 10 cities and metro areas we're working now, to help them to do modeling work, to do tool development, to do analysis around economics, and ultimately to make policy change to transform urban surfaces to deliver the benefits that I was mentioning. We've got 15 funded project partners on this effort. Many of these organizations I'm sure you're familiar with: ACEEE, NASIO, others, across 5 different working groups. So we have a data group, we've got a community engagement group, federal funding group, which has become more complicated lately, but there's still opportunities out there. for funding resilience projects in cities. We've got a policy group, and then we're doing some really interesting health research with the Harvard School of Public Health around 911 calls and Medicare and Medicaid data during extreme heat events, and tracking the impact of those events, and then transforming that into economic analysis that we can bring into some of our tools. So for this program, we're developing three major web tools. We have a decision support tool, which is a geospatial tool. We have the ability to vary. We have our micrometeorological modeling embedded in this tool. And we have the ability to, in a very data-driven way, provide intelligence to the cities about policies, programs, investments. We can layer all sorts of different layers onto this tool to figure out where the most strategic places would be for interventions. We can layer heat modeling, we can layer flooding, mitigation potential, we can layer cooling potential, we can look at energy burden, we can look at demographic data, we can look at highest urban heat island neighborhoods. We can layer all those things together, and it'll help us to help the cities to determine the census tracts and the neighborhoods that would most benefit from these different types of interventions. And so we have this geospatial tool we developed in conjunction with the World Resources Institute and the Trust for Public Lands. And then we have our benefit cost analysis tool. And so all of this is the foundation of our work is really around the economics argument to these types of interventions. And so we can, with our benefit cost analysis tool, we can analyze the economic impact in dollars and temperature reduction, gallons of stormwater mitigated, CO2e, energy, and other characteristics. And you can run this tool in a very quick period. It's very user-friendly. The intention is to have it serve people who are just, an average city policymaker. I used to work for a city government as well. And this tool can be run within, a 5-minute period, and you get some really great data and intelligence out of this effort. And then our third major tool, and this is actually publicly available now, is what we call the Smart Surfaces Policy Tracker. This tool has now, I actually have to update this slide as of this week. We have almost 2,000 policies in this tool to date. It's a searchable web tool, but there's also a best practices section where we have model ordinances, we have policy justification memos, we have all the things that a city would need to, implement a project or a program related to, what we call smart surfaces themselves. And so, this is, quite a comprehensive effort. We are in this phase where we're working right now with the 10 cities and metro areas around the country, including in the Spear region, Dallas and San Antonio. And then we're planning to start a new cohort in 2026. We're going to hopefully add another 20 metro areas around the country, including more metro areas in the Spear region as well. So really excited about this work, delivering essentially data-driven program investment and policy making to the cities. That's really ultimately our goal. And I will stop sharing now and kick it over to Eli, who's going to talk about some really interesting, cutting edge, and I think transformative technology that his company has been working on over the past few years. Eli?
Yeah, great. Thanks, Bill. Yeah, appreciate the opportunity to talk today. Hopefully everyone can see my screen now. So SkyCool is a startup. We're based in Northern California in the Bay Area, and we're commercializing a coating that we developed. It's a plastic thin film that cools passively, and so it's a way to deliver electricity-free cooling. It's most comparable to cool surfaces, so white paints or white roofing that is typically out there. And I'll go into the specifics now. As we're all experiencing, as Bill just mentioned, every summer is hotter than the last. And so, this is going to put stress on people in, urban environments. This is going to increase HVAC energy use. HVAC systems energy for cooling increases when you have hotter temperatures. That's for really two reasons. One, you just need more cooling when it's hotter outside, but two, air conditioners also become less efficient. And so that's going to put strain on grids and put more stress on people who don't have access to cooling systems. And thirdly, this is going to make many buildings that weren't designed for cooling or weren't designed for cooling in mind be very hot to work in and live in. And so at SkyCool, we're trying to address all of these things with this technology. In 2012, 2013, we developed a passive way of cooling. It's this multi-layer optical film, came from Stanford. But essentially, when these materials are outside, even under the sun, they can be cooler than the ambient air temperature. And so this is data from Death Valley. It's near 29 Palms. It's a military base. But essentially, it shows that our film is not only cooler than a white reference surface by about 40 degrees, it's about 10 degrees cooler than the ambient air temperature, which is completely counterintuitive when you think about it. Most surfaces or all surfaces that are outside and under the sun will be hotter than the air temperature, even white paint. This is a thermal image of this technology on a roof. You can see the roof itself is warm relative to the panels, which are cold, or the film, which is cold. And it works through this effect known as passive daytime radiative cooling. And I'll go into how it works in another slide or two. But the concept came out of Stanford. We've gotten a lot of press in the last couple of years. I think there's a lot of interest in ways of cooling passively. We've been supported by the state of California, the federal government, Department of Energy, and we wrote the paper that really first publicized this concept, and it has become one of the top cited papers in physics in a very prestigious science journal as well. But so to understand how this idea works, and what we're doing today, it's helpful to think about this type of cooling, which also occurs at night. And so at night, you will see frost on sky-facing surfaces, even when the air temperature is above freezing. And this really is driven by the same effect. It's called night sky cooling. It really occurs because the sky or upper atmosphere is very cold. And in the extreme, you can think of outer space is very cold. And all these surfaces emit infrared light. That light is transparent to our atmosphere, goes all the way out to space. And so that roof of a car or field will feel the cool of the upper atmosphere. And if there's moisture on it, it can freeze at certain times of the year. And so during the day, we don't typically see this effect because there's a lot of energy that comes from the sun, and it heats up most sky-facing surfaces. It is the reason why our planet is warm. Darker surfaces obviously heat up more during the day, but that's the basic premise. So we're at SkyCool taking advantage of the fact that the upper atmosphere is cold, and we've developed these surfaces that can simultaneously reflect energy from the sun, but also emit this heat to the sky. And that combination we discovered a number of years ago and are now commercializing products around, but it allows these surfaces to stay cooler than the ambient air temperature, even in the middle of the day. And so, we now are developing products that use this, but it's essentially a way to eliminate solar heat gain to buildings. Like I said, the materials can be cooler than the air temperature. They, will last 10 to 15 years. But they can support passive cooling. So it's a way of providing cooling with no electricity, right? Because these materials just need to be outside and under the sky, and they're not, consuming water like evaporative cooling and things like that. And they're, we're making them in the U.S. and they're PFAS free. So one product we're commercializing is a roof, and so the idea is that it would go on top of an existing roof. Or it's a roof coating, I should say. It goes on top of an existing roof, but It will lower roof temperatures by 10 to 15 degrees below the ambient. It will extend the life of the roof. Roofs age because of a number of things, but predominantly driven by thermal cycling and UV light exposure. And so by putting the film on top of the roof, you're really eliminating that. The film essentially can eliminate solar heat gain to buildings. And so this is heat that comes through the roof into the building. It can have a big impact on HVAC loads. And I'll go into that in another slide. And then if you do this at scale, you have the opportunity and the potential to eliminate urban heat islands. Typically, even a white roof, your best-in-class TPO will be warmer than the ambient air temperature, and is certainly better than a dark roof. But yeah, these materials will be substantially cooler than those white roofs and can lead to real cooling islands or essentially eliminate heat islands in cities. And so if you do this at scale, there's the potential to have a big impact on how city environments feel in summers. So just to dive into a little bit more detail on the building scale. So like a traditional roof, white or dark, will be warmer than the ambient air temperature. That is going to have a heat load on a building, and certainly buildings with less insulation will have larger heat coming through the roof. Whereas when you put this type of film on a roof, you're essentially eliminating that solar heat gain and that thermal load on a building, and that has a big impact on HVAC energy spend. It can have a big impact on how many tons of cooling you need to install in a building to maintain thermal comfort. And that's really what this product is focused on, is around avoiding energy use for cooling and avoiding CapEx for HVAC systems. But then again, as always, you put this in cities at scale and large buildings, you have the potential to cool urban environments and not heat them up. And that obviously also has a big impact on energy use for the city and for everyone around it. The impact on building energy use is going to be predominantly driven by roof insulation. I think in Bill's slide, you saw sort of R value versus I think energy use. We're calling this as a similar idea, but in tabular form. When you have less insulation in a roof, you have more heat that comes in through the building. And when you have dark roofs, you'll have more heat. And if you have white roofs, you'll have less heat. But the idea is that when you have a roof that's cooler than the air temperature, then you're actually eliminating that solar heat gain, and you're actually cooling the building just by it being outside. And so that is the high level of the product. But the applicability is really for most types of buildings. We're focused on larger, warehouses, flat roofs, 1 to 2 story buildings, that have sky access. This is not going to necessarily be a good fit for things like skyscrapers, but warehouses, distribution centers, things like that, manufacturing, it would, because of all of the details that I mentioned. Right now we're designing adhesives to work with roofs like TPO, ModBit, metal, and concrete. But the idea is that this film will have a pre-applied adhesive, and it will be relatively straightforward to stick on a roof, sort of like you can see in this photo below. The performance of these films is going to be really driven by their ability to reflect energy from the sun. And so there is, some maintenance, and that's going to be really focused around cleaning the surface, likely at the beginning of the summer. And that should be enough to maintain the cooling performance over a year. And so we've done a number of pilots with this technology. I have sort of just specific case studies that we put together. This is a roof project we did in Southern California. It was a light manufacturing facility in Redlands, but we put the film on the roof and saw a dramatic reduction in the internal temperature. This building doesn't have air conditioning, but yeah, it was able to essentially cool the building by about 11 degrees. And we can directly measure, how much heat enters the building through the roof with sensors. And so that's what you see here. This is just 2 days of data, but it's been operating for over a year. This is a similar film on a much bigger building, we were comparing this test patch to how much heat would go through. In this case, is a white TPO roof, which is a number of years old. But the idea is that the TPO roof, even though it's white, is still much warmer than the ambient air temperature. Is around 135 degrees Fahrenheit in the middle of the summer on a day which was around 100 degrees. But in this case, the film was less than 100 degrees, and we were able to eliminate the solar heat gain. The heat gain that we're measuring, 15 watts per square meter for a building of this size might translate to 200 tons of cooling for the building. And so by putting the film on this roof, and this is a project we're hoping to do early next year, we can eliminate or prevent the installation of that much cooling capacity. And so that's going to reduce peak energy demand. It's going to reduce energy use over the summer. And this is a similar project. This is with a self-storage company, but same idea. We can put the film on roof and significantly reduce roof temperatures, significantly reduce temperatures inside the building. Again, driven predominantly by the fact that these materials are cooler than the ambient air temperature year round. So on the idea of soiling, so this is actually from that public storage site. This is roof temperatures relative to the ambient from last year and this year. But you can see that without cleaning, you see about a 5-degree Fahrenheit increase in surface temperatures, and so that's roughly the cadence that we'd like to probably have some sort of scheduled cleaning for this. But these are robust materials, and they do perform much better than traditional roof coatings or paints, just because those often are porous, and dirt can get in those pores and then reduce solar reflectance. We've also done accelerated aging. These are relatively new materials, but this is roughly equivalent to 10 years or 5 years, excuse me, of outdoor test data, and the materials seem to be holding up nicely in their aging performance. If you have any questions, there's a lot of articles that have been written about the technology. Happy to answer any questions as well. But I appreciate the opportunity to present our technology, and happy to answer any questions that might come up.
Thank you so much, Eli and Bill. There was a kind of a statement that came up, and it was really towards Bill. And I know that you had, answered it in the chat, but I thought maybe we could have a further discussion regarding solar.
Yeah, it is a bit complicated question right at this historical moment, the economics of solar, given what is happening with the federal administration and tax credits and other things like that. But I can say that it often will depend on location. Solar is quite cost competitive in many, probably most places. I know here in Washington, D.C., where I live, you can see a greater than 200% ROI for solar projects. So I even had a guy when I was working for the city government here, and he said that he was like pulling money out of the stock market with solar panels up on his roof. But it certainly will depend on a location to some extent, and then how everything federally shakes itself out. It is quite remarkable. When I first started installing solar panels back in, I worked for a solar company back in the early, kind of late 2000s, early 2010s. And, we were installing solar at something like $8 a watt back then. And, now they're installing it for $1 a watt, and so it's just, and maybe less now. Even I haven't been tracking most recent updates, but it's quite remarkable how quickly the price has come down, which has made it so competitive to the point where this year, for the first year ever, for an entire month, 10% of national energy generation came from solar. So there's a threshold there that's been met this year. That's quite remarkable. And we'll just be growing from an economic perspective, as regardless of what the federal policy is. It's become so inexpensive to install solar and, there's obviously all the other ancillary benefits connected to it.
I don't see any other questions in the chat, so I of course am going to ask you if you all don't mind. So I'm very curious, as well as with the partnership that the two of you have. Can you delve more into that and explain it further?
Partnership between us and SkyCool, or just
Yes,
with us and
between
other organizations?
you and Sky Cool, and then
Uh-huh.
my next question is going to be really kind of asking about really how you partner with some of these local governments
I see.
and further that. So,
I I
and the
got you.
reason why I'm starting like with this two question is
Mhm.
because one is whenever, right, as a local government, you working with a nonprofit and private industry, it's navigating purchasing rules and requirements are very kind of strict guidelines. And so understanding your partnership and then understanding how you all engage with local governments, this is a great information for the people on the call.
Yeah, yeah. I guess I would start. We don't have any formal relationship with SkyCool. We think they're this technology of passive rate cooling films, and there's also coating technologies that are coming out, um, is a game-changing technology from a human health perspective, from an urban heat island mitigation perspective, from an energy efficiency perspective, and other reasons as well. And so we're more just generally interested in that technology because it helps us solve for problems that cities have that we care about. But we don't have any kind of formal relationship with SkyCool. We're just interested in the technology. Um, and then in terms of our relationship with the city government, so we are foundation funded, and we work with the cities and metropolitan regions to do this analysis for them and then to support them on policy and programmatic transformations. And so, we serve in a technical assistance perspective to the cities, but are, fully foundation funded ourselves as a nonprofit organization. So that's kind of our relationship. Generally speaking, each city will be different, or each metro region. Sometimes we work with city staff from, energy planning, sustainability, transportation, across the board. Sometimes it's narrower than that. And then we work with regional, the municipal, metro planning organizations, councils of governments, things like that. And yeah, so it really sort of depends. We recently worked with the city of Atlanta with a city council member there, and they passed probably the strongest cool roof piece of legislation in the country. And so we helped to provide technical assistance for them. They used actually our model ordinance, our model cool roof ordinance for their as they were developing their cool roof ordinance. And so that's a good example. In that one policy for Atlanta, we modeled to over time, as it's implemented over the next couple of decades, reduce peak summer temperature by upwards of 2.4 degrees Fahrenheit. And in the hottest neighborhood in the city, more than 6 degrees Fahrenheit, just from that one piece of legislation. So that's kind of a good story, a good example of how we support the cities using this data-driven approach. We were able to provide really interesting information, to the point I might be going too deep here, but one of the city council members who was a little bit, he's asking valid questions and maybe a little bit more skeptical, was saying, don't we have a lot of trees here in Atlanta? Aren't most of those covered by tree canopy and shade? And we said, and asked three or four other questions. The council member staffer who we were working with came back to us and said, I can't imagine you guys can answer these specific 5 questions. Like, they're very detailed. And we were like, oh yeah, we can totally do that. We'll have the answers to you tomorrow. Turns out 74% of all the steep slope roof area in Atlanta is not covered by shade and tree canopy. And that was convincing enough for that council member who was asking the questions to actually, vote for the bill. It was end up being unanimous vote on the city council. So that's kind of a good example. Eli, what would you add to that? I don't actually know how you all, work with city governments.
Yeah. I mean, right now we're piloting our technology with different building types. So in Las Vegas, for example, we're working with water utility to demonstrate the technology as a way to reduce cooling on buildings to directly offset evaporative cooling. So this is spraying water and air to cool buildings. We've done projects with lots of building owners to demonstrate it. I mean, I think it's as of now, most cities don't quantify the value of reduction in urban heat islands, and so we are really focused on improving thermal comfort on specific buildings. And so we often work with building owners, people who operate factories or warehouses that are maybe currently getting too hot to work in because of rising temperatures, and we provide a way to cool building and cool buildings, excuse me, without energy or big OpEx costs. So.
Yeah, and there's another uh, manufacturer of the passive rated cooling films that's doing a pilot with the city government in Phoenix right now. And so they're doing a bunch of testing and working with the city government there. So I could see other opportunities like that around the country. I know the cities that we're working with are really interested in this technology because of its multiplicative benefits.
For sure, yeah. But we've done projects or thinking about projects with bus stops, for example,
Mhm.
often can't be cooled directly or actively, and it can be very hot to stand outside in the sun. Shade structures in parks, canopies, in cities, and then I think for us as a company, we're focused on warehouses, manufacturing facilities where buildings weren't designed for cooling. They don't have a lot of roof insulation. They don't have roof structures to hold HVAC units, and they don't often have the power infrastructure to run HVAC systems, and so it can be costly to install air conditioning in those cases. And so like putting film on a roof is far simpler and more cost effective.
Yeah, I was just thinking about material recovery facilities. Generally, those aren't air conditioned, and that would be very helpful for the staff that are working in there. And then I was just thinking about when a company receives an OSHA violation for a facility for being too hot, what a great partnership, how they can approach that.
For sure. Yeah. Yeah. I mean, there's worker retention challenges that a lot of companies, we speak to a lot of companies that this is a common problem is it's too hot to work in. It's hard to keep folks in the factory because, they want to work in a factory next door across the street that has air conditioning and it's much cooler. And I mean, it is, very taxing on your body to be in, 100-degree environment or 90-degree environment.
Yeah, I was
Seems
just
like,
thinking, go ahead.
I was just gonna say, it seems like data centers could be another good application, Eli, given the wild amount of energy consumption that they do. Is that a space you're thinking about, or just curious about that?
Yeah. So we have two products. The roof concept, I think, would maybe be less applicable to data centers. Data
Mhm.
centers represent a type of building that has just an enormous amount of internal heat generation. And so
Yeah.
like, solar thermal loads from the roof are much smaller relative to that internal heat generation.
Mm.
Um,
Yeah.
yeah, we are also creating a cooling panel which can directly cool those data centers and can do so without significant amount of electricity. And so that is a product and a concept that we're also developing.
Interesting.
Yeah,
Very interesting. Um, there was another question in the chat. What are some of the initial and long-term cost considerations for the radiative cooling films in comparison to other passive techniques or lack thereof?
for sure. Yeah. So there are, I guess, a couple different passive cooling strategies. There's I guess that are more traditional, so that they often require completely new construction of buildings. So they'll have walls facing certain directions to reduce solar heat gain, for example. Not have windows facing south, but they can be quite costly just because it requires a new structure, or maybe if it's done from the beginning, it's yeah, less costly, but still more than traditional design. In the passive coin space, like what we're doing, radiative coin, there are paints and films. Um, Paints can be very low cost. I think the primary challenge with paints is that they typically don't maintain their reflectance over time. And so if you put even a cool roof paint on a building, it needs to, if you're using it for that functionality of cooling, it needs to be likely replaced every couple of years. We were I've thought a lot about this space, and that sort of justified or sort of pushed us in this direction of a film. Films can be more robust, more durable, easy to clean them, and that is why we're focused on that. So yeah, there are maintenance costs, or at least we would recommend cleaning the roof at least once a year to maintain that reflectivity. But the films themselves should be able to maintain their optical properties for 10 to 15 years. Yeah, I think that hopefully answers most of the question.
Bill, do you have anything to add to that?
No, I think that definitely covered it. There are some more advanced rate of cooling coating technologies that are coming to the market that are not sort of traditional paints. They're ceramic based, and others that will be more easily cleaned, and the rain will more easily clean, and otherwise will be easier to clean and won't be as porous as the current offerings in the like the cool roof coating world. But the films are they're they're probably always going to be easier to keep clean, keep functioning the way that they are. But yeah, nothing much to add there.
And I have a silly question. How do you go up there and clean them? Is it just, Dawn and a spray washer? So do you have to have access to a substantial amount of water for that roof? And
Yeah.
it
It
just,
would just be spraying with water. I think that's maybe how typically roofs might be cooled. I mean, you could imagine in the future like a Roomba for your roof, which cleans it seasonally. And I think it's not a lot of water in the grand scheme of things, but yes, it would require water for sure.
uh, well, just like with that operations lens of thinking about how do you
Definitely.
coordinate that? How do you actually like kind of really do you work with a service provider that brings their own water tank? Those are the kind of things that I'm thinking about whenever you go,
Sure.
okay, I have this product. Just so I was just curious about that. My other statement was with the cool roofs, have you all? Because I was just thinking, bringing it back to local governments. Most local governments, they have facilities where, right, you were mentioning working with parks and community centers, something that is not known very often. We think about community centers and recreation centers as a hub, but they're also at times underfunded and their HVAC systems go down often. And so there's no refuge because they have to close for the community members to utilize. So I was just thinking what a great opportunity to partner with some community centers that are in some regions that are fairly warm. And then that's just wearing my former parks hat. And then I was also just thinking about with local governments and how most of them have fleet facilities and how they're having to really kind of look at, okay, how is this affecting my employees? And they're having to keep the bays and doors open. So it's like, what a great opportunity in that aspect. Um, well, we don't have any more questions. I so appreciate you all both spending your time and expertise and sharing it with the world here in Texas, and also this will be uploaded to YouTube. Um, I have a list, Bill, to reach back out to you for resources. And Eli,
Yeah.
I will have a list for you as well. So all of you who have attended the webinar live today will receive those resources. And those of you who watch the webinar later on YouTube, feel free to email me and I can share them. This has been a fantastic conversation. And you all will be having a conversation as well at our upcoming Spear workshop. So I'm excited about that in September. Uh, and so thank you both again for what you do for our country and the environment and trying to shift our energy consumption. And thank you guys for taking time to attend and learn more.
Thank you all. Really appreciate the time here.
I am going to put the link to our Spear survey in the chat. Please take a moment to respond to that. And yeah, is there anything that you guys want to add before we sign off?
Yeah,
Okay,
nothing for me. Yeah, I really appreciate it. Appreciate the space.
fantastic. All right.
Take
Well,
care.
thanks. Thanks for sharing your lunch.